Hi, welcome back to my channel. My name is Gina. We've already derived the 4 kinematic equations for motion under constant acceleration. And we've looked at 2 examples for motion in a straight line. 1 horizontal motion and 1 vertical motion. If you haven't watched the videos, I'll put the link up there. So in this video, we are going to look at an example for motion in 2 dimensions. For motion in 2 dimensions, we can separate the x and the y component. Let's look at this example. A football is kicked with an initial velocity of 20 meters per second at an angle of 35 degrees with the horizontal. We want to find the time of the flight, the horizontal displacement, and the peak height of the football. Let's do a simple sketch of the situation. So you have a football on the ground, and you kick this football with an initial velocity that is 20 meters per second with an angle 35 degrees with the horizontal. And this football will have a projectile motion and will eventually hit the ground. So in this question, we want to find the time of the flight, which is delta t, and the horizontal displacement, delta x, which is the distance here. And in part C, we want to find the peak height of the football. Let's call this h, which is this part. How about the knowns? We know the initial velocity, which is 20 meters per second with the angle 35 degrees. We can decompose that into the initial velocity in the x direction and the initial velocity in the y direction. In the x direction, it will be the initial velocity times cosine of the angle, 35 degrees. That is 20 times cosine of 35, which is around 16.4 meters per second. In the y direction, the velocity is the magnitude of the initial velocity times sine of 35, which is 11.5 meters per second. Now let's level our reference point. Let's define the initial position as 0, 0. And y increases upward and x increases to the right. For part A, we want to find the time of the flight. We can use the second equation in the y component, that is delta y equals the initial velocity in the y direction times delta t plus half times acceleration times delta t squared. For delta y, it equals to 0 because the initial height is at the ground, and the final position when it hits the ground, it will also be at the ground. So delta y is 0. And initial velocity in the y direction is 11.5 meters per second times delta t plus half times the acceleration in the y is negative 9.8 times delta t squared, which equals to delta t times 11.5 minus 4.9 times delta t. And this equals to 0. So delta t could be 0 second, or 11.5 divided by 4.9, which is 2.35 seconds. We got 2 answers for delta t because the final height equals to 0 when the ball is at the initial position or at the final position here. And we want to find the time of the flight, so the non-zero answer is the answer that we are looking for. So for part A, the time of the flight is 2.35 seconds. Now let's look at part B. We want to find the horizontal displacement, so let's focus on the x components. we want to find delta x. We know that the initial velocity in the x direction is 16.4 meter per second. And from part A, we also know that delta t is 2.35 seconds. Furthermore, we know that the acceleration in the x direction is 0. Then we can use the kinematic equation that has delta x and the other nodes. For example, the second equation. Delta x equals to initial velocity times delta t plus half times acceleration times delta t squared. We know that the acceleration is 0 in the x direction, so the second term is 0. So this equals to the initial velocity, 16.4, times delta t, 2.35, which equals to 38.54, and the unit for displacement is meters. Now let's look at part C. We want to find the peak height of the football. For part A and part B, we define the initial point as right before the ball was kicked, and the final point is when the ball hits the ground. But for this question, we want to find the peak height of the football. So instead of defining the final position as when the ball hits the ground, we are going to define the final point as the maximum height of the trajectory. And since we want to find the height, so let's focus on the y component. So the nodes are the initial velocity in the y direction, which is 11.5 meters per second. We also know the final velocity in the y direction. Since in the y direction, at the maximum height, the velocity in the y direction is 0. We also know the acceleration in the y, which is negative 9.8 meter per second squared. And we want to find the delta y. So let's look at the four equations. We don't have delta t, so equations 1, 2, and 4 are not the equations we're going to use. So let's use equation 3. Final velocity squared equals initial velocity squared plus 2 times acceleration times delta y. Let's substitute the nodes we have. Final velocity is 0. And this equals to initial velocity squared, that is 11.5 squared, plus 2 times acceleration, which is negative 9.8, times delta y. Then we can solve for delta y. Negative 4.9 times delta y equals to negative 11.5 squared. So delta y equals 11.5 squared over 4.9, which is 26.99 meters. So with this velocity, 20 meters per second, with 35 degrees with the horizontal, the ball can reach up to 26.99 meters in height. And that's the end of the video. If you like my videos, please like and subscribe, and I'll see you in the next video.